Imagine this. The year is 2080. You step outside onto the surface of Mars, your boots pressing into the fine, rust-colored dust. The sky above is not blue, but a hazy orange. In the distance, a massive dome glows under the dim sunlight, sheltering a self-sustaining colony of humans. Inside, crops are growing under artificial light. Engineers are designing habitats for future settlers, and children, born on Mars, have never set foot on Earth. Sounds like a scene from a sci-fi movie, right? But what if I told you? This could be our reality. For centuries, Mars has been a planet of mystery, a distant red world that once harbored rivers and lakes, but now it's cold, dry, and lifeless, or so we think. Despite its harsh conditions, Mars remains the most promising candidate for human colonization. Visionaries like Elon Musk, NASA scientists, and private space agencies are pouring billions into making this dream a reality. Some believe that within our lifetime, humans will not just visit Mars, but live there permanently. But is this even possible? Can we truly turn Mars into our second home, or is this a fantasy doomed to fail? To answer this, we need to look at the facts, the science, the technology, the challenges, and the risks. How will humans survive on a planet with almost no atmosphere, deadly radiation, and no liquid water? What about food, fuel, and long-term sustainability? And most importantly, will we ever see the first Martian city? The truth might surprise you. The case for colonizing Mars. Why it's more than just a dream. Before we talk about the challenges, let's address one key question. Why Mars? Why not the Moon or another planet like Venus? The answer lies in three major factors: habitability, survival, and exploration. Mars is the most Earth-like planet. If we compare planets in our solar system, Mars is the best option for human life. Unlike Venus, which has scorching 900-degree Celsius, 475-degree Celsius temperatures, and crushing atmospheric pressure, Mars is far more forgiving. Here's why. A 24.6-hour day. Mars has a day-night cycle almost identical to Earth's, only 40 minutes longer. This makes it easier for humans to adapt and maintain a natural sleep cycle, unlike the Moon, which has 2-week-long days and nights. Water ice exists. Scientists have confirmed that vast amounts of frozen water exist beneath the surface of Mars. If we can extract and purify it, we'll have a critical resource for drinking, farming, and producing oxygen. Seasons and weather. Mars has seasons similar to Earth due to its tilted axis. While it's much colder, the presence of weather cycles makes it less extreme than some other celestial bodies. Mars as humanity's backup. Plan Stephen Hawking once warned that humans must become a multi-planetary species to avoid extinction. Why? Because Earth is vulnerable. Whether it's nuclear war, asteroid impact, climate catastrophe, or a deadly pandemic, a single disaster could wipe out civilization. Colonizing Mars wouldn't just be about exploration, it would be our lifeline. If something were to happen to Earth, a self-sustaining Martian colony could preserve human knowledge, culture, and survival. The spirit of exploration, from crossing oceans to landing on the Moon, humans have always pushed boundaries. Mars is the next great challenge. Just like the great explorers of the past, those who step onto Mars for the first time will be pioneers, risking everything for the future of humankind. But here's the harsh reality, the harsh truth. Mars is not a paradise. While Mars is our best option, it's still an incredibly dangerous and unforgiving place. Let's break down the biggest obstacles to human survival on the red planet. Mars wants to kill you. The atmosphere and temperature. First things first, Mars has no breathable air. The atmosphere is 96% carbon dioxide, meaning if you stepped outside without a spacesuit, you'd pass out within seconds and die shortly after. Unlike Earth, there's almost no protective ozone layer to block harmful UV radiation, and then there's the temperature. Mars is freezing. On average, it's 80 degrees, 62 degrees C, and at night it can drop as low as 200 degrees, 929 degrees, near the poles. Without proper insulation, any exposed human would freeze solid in minutes. Cosmic radiation, a silent killer. On Earth, we're protected from deadly solar radiation thanks to our thick atmosphere and magnetic field. Mars has neither. That means anyone living on the surface would be bombarded with radiation levels 250 times higher than on Earth, increasing the risk of cancer, brain damage, and genetic mutations. NASA estimates that astronauts on a 6-month journey to Mars would already receive their lifetime safe limit of radiation exposure before they even land. Without proper shielding, long-term exposure on Mars could be fatal. 3. Gravity problems. What happens to the human body? Mars' gravity is only 38% of Earth's. While this might sound fun at first, imagine being able to jump 3 times higher. It has serious long-term health effects. Bone and muscle loss. Just like astronauts on the ISS experience muscle atrophy, long-term Martian settlers could suffer from severe bone density loss, making them fragile and weak over time. Unknown. Effects on pregnancy. Could a baby be born safely on Mars? Scientists don't know. Gravity plays a crucial role in human development, and no mammal has ever given birth in low gravity. The dust that could destroy everything. Mars isn't just dusty. It's covered in a fine, toxic dust that contains perchlorates, which are harmful to humans. This dust gets into machinery, clogs systems, and could contaminate water and food supplies. And let's not forget the massive dust storms that can cover the entire planet for months at a time, blocking sunlight and reducing power from solar panels. With all these dangers, how can humans ever hope to survive on Mars? The answer lies in technology, innovation, and an unprecedented global effort. Overcoming the impossible. How humans can survive and thrive on Mars. For Mars colonization to succeed, we must solve 4 critical challenges: breathable air, sustainable food, reliable shelter, and long-term survival. Scientists, engineers, and visionaries like Elon Musk believe that with the right technology, these problems can be solved. But how? Creating a breathable atmosphere. The oxygen problem. Mars' atmosphere is unbreathable. 96% carbon dioxide and almost no oxygen. To survive, we must create our own oxygen. NASA's MOXIE experiment, sent to Mars aboard the Perseverance rover, has already proven that oxygen can be extracted from Mars's atmosphere. MOXIE works by splitting carbon dioxide, CO2, into carbon, monoxide, CO, and pure oxygen, O2. A scaled-up version of this technology could produce enough oxygen for an entire colony, but that's not the only solution. Scientists are also exploring algae and bacteria that can convert CO2 into oxygen, much like trees on Earth. If successful, Mars' first oxygen farms could be biological rather than mechanical. Until we have large-scale oxygen production, colonists will live in sealed habitats, wearing spacesuits every time they step outside. The food crisis. What will Martians eat? You can't just plant seeds in Martian soil and expect them to grow. Mars's soil lacks nutrients, contains toxic chemicals, and has almost no water. So how will settlers get food? The answer: hydroponic and aeroponic farming. Hydroponic farming. Instead of soil, plants are grown in nutrient-rich water solutions under artificial light. Aeroponic farming. Plants grow in misted air. Using far less water than traditional methods, NASA and private companies are testing ways to grow crops using LED lighting and recycled water. Crops like potatoes, wheat, and soybeans have already been grown in simulated Martian soil. In fact, experiments on the ISS have shown that astronauts can grow and eat fresh vegetables in space. For protein, future Martians might rely on lab-grown meat, algae, or even insects. While that might sound unappetizing, a self-sustaining food system is the only way humans can survive long-term. The shelter dilemma. Where will we live? Mars's surface is deadly, freezing cold, high radiation, and constant dust storms. Building. A safe habitat is the first priority. There are several proposed solutions. Underground lava tubes. Mars has massive underground lava tubes, remnants of ancient volcanic activity. These natural tunnels could be perfect for shelter, protecting colonists from radiation and extreme temperatures. Scientists believe some tubes are large enough to house entire cities beneath the surface. B. 3D printed habitats. NASA has already tested 3D printing technology using Martian soil simulants. In the future, robotic rovers could build habitats before humans even arrive using Mars's own resources. This method, called in situ resource utilization, ISRU, would eliminate the need to transport heavy building materials from Earth. Das C. Inflatable domes. Another possibility is self-deploying habitats, lightweight domes that inflate and harden once they reach Mars. These could provide temporary shelters while permanent bases are built. Whichever solution we choose, radiation shielding will be critical. Some proposals involve covering habitats with layers of ice or Martian soil to block harmful radiation. Water. The key to long-term survival. Water is essential, not just for drinking, but for growing food, making oxygen, and producing rocket fuel. Fortunately, Mars has water ice. The challenge is extracting and purifying it. Possible solutions include melting subsurface ice deposits using solar-powered heaters, condensing atmospheric water vapor, though this would require large-scale infrastructure. Chemical extraction from hydrated minerals in the soil. SpaceX, NASA, and other agencies are already mapping Mars's largest underground ice reserves, searching for the best locations for future colonies. The journey to Mars. How will we get there? Getting humans to Mars is just as difficult as surviving there. A one-way trip takes 6 to 9 months, and that's only if we launch during the right orbital window, which happens once every 26 months. Right now, the most promising plans involve Starship, SpaceX's fully reusable rocket. Starship is designed to carry up to 100 people per trip, making mass colonization possible. But space travel is incredibly dangerous. Cosmic radiation exposure during the journey, long-term effects of microgravity on the human body, psychological stress of being isolated for months. Astronauts on the first missions will have to endure cramped spaces, limited resources, and extreme risks. The trip to Mars isn't just a technical challenge, it's a mental and physical endurance test. Terraforming Mars. Can we make it more like Earth? Right now, every plan for Mars colonization involves sealed habitats. But what if we could change the planet itself? Terraforming is the idea of modifying Mars to make it more Earth-like, warmer, with a thicker atmosphere and liquid water. Theoretically, this could be done by releasing greenhouse gases like CO2 and methane to warm the planet, melting the polar ice caps to increase atmospheric pressure, introducing microbes and plants that can produce oxygen. However, terraforming would take centuries or even millennia. Some scientists argue that Mars may never be truly habitable and that colonization will always require enclosed artificial environments. But despite these challenges, progress is being made. SpaceX, NASA, and other organizations are actively working on technologies to make Mars livable. So, will humans ever colonize Mars? In the next section, we'll explore the timeline, the risks, and what the first human city on Mars might look like. But before we continue, is this the future you'd want to be a part of? The reality of Mars colonization. When will it happen? Despite all the challenges, humanity is closer than ever to making Mars colonization a reality. But when will it actually happen? The timeline. How soon can we get there? Elon Musk's SpaceX aims to send the first humans to Mars in the 2030s, with the ideal long-term goal of building a self-sustaining city. NASA's Artemis program and Gateway station around the Moon will serve as a stepping stone for deeper space missions, including Mars. However, realistic projections suggest that a fully functional colony, with permanent settlers, food production, and infrastructure, could take 50 to 100 years. The risks. Can we actually survive? Even with advanced technology, Mars is not Earth. Colonists will face psychological isolation, being millions of kilometers from home, health risks, radiation exposure, bone loss, and unknown long-term effects, unpredictable disasters, equipment, failures, food shortages, and harsh Martian storms. To survive, humanity must develop better life support systems, AI-driven automation, and sustainable energy sources. The first human city on Mars. The first settlement will likely be a research outpost, similar to Antarctica's stations. Over time, it will expand into a network of domes, underground cities, and industrial hubs, producing oxygen, water, and fuel on site. If successful, Mars colonization could be humanity's greatest achievement, a second home, ensuring our survival, beyond Earth. But will it be a utopian dream or a dystopian struggle? Will humans thrive, or will Mars remain a graveyard of ambition? Let me know your thoughts in the comments below. Would you live on Mars?